All right, so let's go on to some trickier, slightly trickier integrals. Here's an example. The integral of, say, x cubed times x to the fourth plus 2 to the fifth power dx. This is a function which you actually do know how to integrate because we already have a formula for all powers. Namely, the integral of x to the a is equal to this, and even if it were a negative power, we could do it. So it's OK. On the other hand, to expand the fifth power here is quite a mess, and this is just a very, very bad idea. There's another trick for doing this that evaluates this much more efficiently, and it's the only device that we're going to learn now for integrating. Integration actually is much harder than differentiation symbolically. It's quite difficult and occasionally impossible. And so we have to go about it gently. But for the purposes of this unit, we're only going to use one method, which is very good. That means whenever you see an integral, either you'll be able to divine immediately what the answer is, or you'll use this method. So this is it. The trick is called the method of substitution. And it is tailor-made for the notion of differentials. So tailor-made for differential notation. The idea is the following. I'm going to define a new function, and it's the sort of messiest function that I see here. It's u is equal to x to the fourth plus 2. And then I'm going to take its differential, and what I discover if I look at its formula is, and the rule for differentials, which is right here, its formula is what? 4x cubed dx. Now, lo and behold, with these two quantities, I can substitute, I can plug in to this integral, and I will simplify it considerably. So how does that happen? Well, this integral is the same thing, as, well, really I should combine it the other way. So let me move this over. So there are two pieces here, and this one is u to the fifth, and this one is a quarter du. So that makes it the integral of u to the fifth du divided by 4. And that's relatively easy to integrate. That is just a power. So let's see. It's, it's just a 20th u to the, whoops, not a 20th. The antiderivative of u to the fifth is u to the sixth with a 1/6. So it's 1 over 24 u to the sixth plus c. Now, that's not the answer to the question. It's almost the answer to the question. Why isn't it the answer? It isn't the answer because now the answer is expressed in terms of u, whereas the problem was posed in terms of this variable x. So we must change back to our variable here, and we do that just by writing it in. So it's 1/24 x to the fourth plus 2 to the power 6 plus c. Right? And this is the end of the problem.